Hey guys, welcome back. This time we're going to continue our conversation in chemistry. In particular, we're going to be looking at the language of chemistry and introducing two new terms, elements and atoms. Why I taught chemistry in anatomy physiology class? Well, let's look at the human body. When we were discussing the human body in this course, we're going to be looking at its anatomy, which is going to be made up of chemicals, and we're going to be looking at the physiological events, which are also made up of chemicals. In reality, if you think of the human body, it really is just simply a sack of chemicals, with the largest compound in that sack being water, and then all the cells floating around in water. Again, what makes up the cells? Chemicals. Chemicals like carbohydrates, nucleic acids, proteins, and lipids. So for you to be a healthcare provider, it'll probably be to your advantage to understand a little bit about the chemistry that makes up the human body. Now, the chemistry that makes up the human body starts with the elements that you can find listed on a periodic chart. Depending on the periodic chart you look at, there'll be anywhere from 116 to 118 elements. 92 of those are found in nature. And of those 92, in the human body we have two categorizations. We have the essential elements, and there are 4 essential elements making up 96% of the overall body mass. And then there'll be those other elements that we call trace elements. Trace elements represent less than 1% of the overall body mass. Now the 4 elements that are essential elements in the human body are going to be carbon, oxygen, nitrogen, and hydrogen. Notice from those 4 though, we did not list things such as iron, calcium, sodium, or potassium. But if you take a look at an IV bag, which all of us could agree is a very essential components that are found in our body, all of those elements are actually found in an IV bag. It's just simply that they're found in the human body at less than 1%, so that makes them trace. Now we're going to spend some time during this course taking a look at the periodic chart. I will say right off the bat that I do not expect you to memorize the periodic chart. In fact, I've given you a link to a site in which you can go and download a copy of the periodic chart. I simply want you to leverage the information that's found on that periodic chart. Understand why it's written in rows and why it's written in columns. On test day, I encourage you to have the periodic chart there because I want you to be able to use it, not memorize it. Now let's take a look at how that periodic chart is written. Notice that there's a series of letters there in boxes. Each one of those boxes represents a unique element. Each unique element has its own atomic symbol. Now the atomic symbol will be the 1 or 2 letter representation in the box. Notice if it's got 1 letter, it's always capitalized. If it has 2 letters, the first letter is capitalized and the second letter is in lowercase. Take a look at hydrogen, for instance. Hydrogen has the atomic symbol of H. Take a look at oxygen. Oxygen has the atomic symbol of O. Take a look at helium, though. Helium has the atomic symbol of He. Notice that E is in lowercase. Now, where do these letters come from? Well, frequently they're going to represent the first letter of the English-derived name for the element. But think about that. There's 26 letters in the alphabet, and there's over 100 elements. So we would quickly run out of letters if we did one at a time. So it has been convenient that at times we will take the first letter and either the second or some other letter in the name of the English-derived for that element and use that as the atomic symbol. You can see that with helium again. You can see that with neon right below it. You can see that with magnesium where they actually took the first letter and the third letter. But then you've got those unique oddities. What's up with potassium? Potassium has atomic symbol of K. There's no K in the English-derived name of potassium. We have to go back and look at the Latin-derived name of potassium and we'd see that it's Catrium. And so we take the first letter there. Take a look at sodium, another key element that's going to be found in the human body. Notice that with sodium, it's Na. Where did Na come from? Again, go back to Latin. Latin-derived name for sodium is natrium. And so they took the first two letters there. Now, if I wanted to look at one unit of an element, say one representative unit of hydrogen, then that's what's known as an atom of hydrogen. And an atom of hydrogen will have all the physical and chemical characteristics that would be representative of hydrogen. Quickly, what are physical and chemical characteristics? Physical would be, how does it look? How does it burn? What does it smell like? Does it have a rough surface or a smooth surface? The chemical is, how does it interact with other chemicals to create chemical bonds? Oxygen, then, an atom of oxygen would be one representative unit of oxygen and all the things that make it up. And that's what we're going to discuss in the next video, are the things that make up an atom of an element. Now it's time for you to reflect for a few moments. Sit back, reflect on what matter is, what energy is, what are the types of energies, what are the forms of energy, what are elements, and what are atoms. See you next time. Have a good day.